In this tutorial, we will cover the basics of how pointers and computer memory works. We will begin by looking at variables at both an abstract level and a low level. We will briefly cover how computer memory works. Finally, we will go over how pointer variables work. At a high level, variables are containers that store data. At a low level, variables are named allocations of memory. If a variable is like a box, then a data type is like a box size, and the data is the content. A char variable, for instance, takes up 1 byte of memory. An int variable takes up 4 bytes. A double takes up 8 bytes. While the contents of a variable can change during program runtime, the variable does not change. It keeps the same data type and the same allotment of memory for its lifetime. Of course, some variables can be created and destroyed during runtime. These variables are called dynamic variables, and they are assigned using a special kind of data type we call a pointer. We will go over pointers in just a moment. First, let's go over how variables are created, destroyed, and managed. In C and C++, there are 2 times in which variables are created. The first time is when the program compiles. The second time is when the program runs. After you write a program, the compiler translates the code into machine-level instructions. Those instructions are then loaded into the computer's memory. Finally, those instructions are fed into the processor so that they can be executed in sequence. Variables that are created during compile time will occupy a fixed amount of memory for the duration of the program. These are safe variables since they won't take up any more memory than they are assigned. Also, they are assigned free space during compile time. They won't overwrite memory cells that are currently in use. Dynamic variables, which are created during runtime, are not so safe. When you create a dynamic variable, you could assign it to any memory address and therefore accidentally overwrite something important. Furthermore, since garbage collection in C++ is not automatic, you have to programmatically deallocate your dynamic variables. Otherwise, you could clog up the memory and cause a stack overflow. When a stack overflow occurs, the memory is full. The computer has nowhere to put new instructions, so it crashes. Now that we understand how dynamic variables can be dangerous, we can learn to use them properly. A pointer is a special kind of data type. Unlike primitive data types, which store things like ASCII characters, integers, and floating point numbers, a pointer stores a memory address. We call them pointers because they act like road signs that point to a destination. To declare a pointer, we use the primitive data type for our destination variable, followed by an asterisk. The primitive data type plus the asterisk form the pointer data type. The pointer variable will be used for storing memory addresses of variables that correspond with the pointer's primitive type. When a pointer is first declared, it doesn't contain a memory address. A good practice for initializing pointers is assigning them to null. A pointer can be used to indirectly change the content of some variable. Here's an example. Suppose we want to change the char variable grade from F to A without touching the grade itself. We can do this as long as we have the address of grade. We can return the address of a variable by putting an ampersand in front of it. We can save this address in a pointer variable. Let's name this pointer something obvious, like grade pointer. Now we can view the contents of grade indirectly by using our grade pointer. We can also change the contents of grade with our grade pointer. To access or make changes to the value in grade, we put an asterisk in front of grade pointer. An array is a homogeneous and continuous block of memory. By homogeneous, I mean that all elements of the array are the same data type. By contiguous, I mean that the elements are physically located right next to each other in memory. If we return the address of an array, we will get the address of the first element. We can traverse an array by using a pointer. Suppose we assign a char pointer p to hold the address of a char array. We can traverse through the array by incrementing the pointer. We can create dynamic arrays using pointers. The following code accepts an array size from console input during runtime. Then it creates an array of that size. We use the keyword new when we create a dynamic variable. When we are done using the dynamic array, we have to deallocate its memory using the delete operator. Hopefully now you have a basic understanding of how pointers in memory works. This is important to know if you want to understand how computers work internally. For more interesting content, please visit my blog at carlinabytes.com. Thanks for watching.